Hello there, and welcome to the Sleepy Science Secrets. Tonight, we are going somewhere very rare, somewhere most people only visit once in a lifetime, if they are lucky enough to find themselves in just the right place on just the right day. We are going to stand beneath a darkening sky in the middle of the afternoon while the birds grow quiet and the wind stills and the world takes a slow, soft breath. In August of 2026, a total solar eclipse will pass over parts of our world, moving silently across Spain, across Iceland, across northern Africa. And for just a few minutes, day will become something else entirely. Not night, not noon, but something in between that has no other name. A gentle twilight that arrives without warning and leaves before you are ready to let it go. Stars will appear in the daytime sky. Animals will grow still. The air will cool and soften. And the sun, that great blazing ordinary sun we forget to notice, will become the most beautiful thing anyone has ever seen. Come with us now. There is nothing to hurry toward. Just settle in. Let your shoulders drop and let the story begin. You have probably stood in the sunshine thousands of times without thinking much about it. The light falls. You squint. You look away. But tonight, let yourself imagine it differently. Imagine that light as a living thing. A river of tiny particles called photons, rushing outward from the heart of the sun in every direction at once, crossing 150 million kilometers of empty space in just 8 minutes and 20 seconds. That is the exact time it takes for sunlight to reach you. So every time you step outside on a bright day, you're standing in light that left its source before your breakfast was finished. The sun is not burning the way a campfire burns. There is no wood, no fuel being eaten away. Deep in its core, the sun is doing something far more extraordinary. It is fusing hydrogen atoms together, turning them into helium, and releasing enormous amounts of energy in the process. This is called nuclear fusion, and it has been happening continuously for about 4.5 billion years. The sun is not getting smaller so much as it is very, very slowly changing at a pace so gentle it is invisible to any human timescale. When you think about how old the sun is, 4.5 billion years, it becomes hard to hold in your mind. But there is a soft way to understand it. If you compressed the entire history of the sun into a single year, all of human civilization would happen in the final few seconds of December the 31st. Everything you have ever known, every story ever told, every eclipse ever watched in wonder, all of it would fit into a breath at the very end of an almost incomprehensibly long day. The moon, which will play such a central role in our story tonight, formed in a rather dramatic way about 4.5 billion years ago. A body roughly the size of Mars, scientists call it Theia, struck the early Earth, and the debris from that collision gradually gathered together in orbit, forming our moon. So, when you look up at the moon on a quiet night, you're looking at what is partly the ancient Earth itself, reshaped by collision and time and gravity into that familiar pale circle. The moon is not perfectly round, you know. It is very slightly egg-shaped, and it wobbles gently as it travels around us. This wobble is called libration, and because of it, we can actually see about 59% of the moon's surface over time, even though the same side always faces us. The moon is tidally locked to Earth, rotating at exactly the same rate as it orbits, which is why you never see its far side from the ground. It is like a dancer who always faces the same direction as they circle the room. The distance between the Earth and the Moon is not fixed. The Moon moves in an elliptical orbit, which means sometimes it is closer, about 356,000 kilometers away, and sometimes farther, about 406,000 kilometers. When it is at its closest point, it looks a little larger in the sky. When it is farthest, it looks a little smaller. This matters enormously when it comes to eclipses. Here is perhaps the most astonishing coincidence in all of nature. The sun is about 400 times wider than the moon, and it is also about 400 times farther away. This means that from where we stand on Earth, the sun and the moon appear almost exactly the same size in the sky. Not approximately the same, not roughly similar, almost perfectly matched. This is not something that had to happen. It is not a law of physics. It is simply an extraordinary piece of luck, a cosmic coincidence so precise that no other planet in our solar system experiences a total solar eclipse the way Earth does. And because of it, when the moon passes between us and the sun, it can cover it completely, hiding the brilliant disk and revealing the pale, glowing crown that surrounds it. That crown is called the corona, and it is one of the most beautiful things in the sky. Under ordinary circumstances, the corona is completely invisible. The sun's surface is so bright that it washes out everything around it, the way a lamp in a dark room makes the rest of the room invisible until your eyes adjust. But during a total eclipse, when the moon covers the disk exactly, the corona blooms into view, a halo of pale white light, softly structured, reaching outward from the sun's hidden face in delicate streams and loops and feathers. It looks like light breathing. The corona is extraordinarily hot. This is one of the great mysteries of solar science. The surface of the sun, called the photosphere, is about 5,500 degrees Celsius. But the corona, which is the outer atmosphere, farther from the center, is millions of degrees hotter. This seems to make no sense. It is a bit like walking away from a campfire and finding that the farther you walk, the warmer the air becomes. Scientists are still working to fully understand why this happens, though they suspect it has to do with magnetic waves carrying energy outward from the surface. Every eclipse gives researchers a few more precious minutes to study this mystery. Along the edges of the eclipsed sun, you might notice tiny pink and red flames leaping outward from behind the moon's edge. These are called prominences, and they are enormous loops of plasma, superheated gas, arching hundreds of thousands of kilometers above the sun's surface, guided by invisible magnetic fields. They are made of the same stuff as everything else in the sun, but they glow with a particular rosy color that makes them look almost tender, almost gentle, against the black disk of the moon and the pale corona beyond. If you are quiet enough during totality, the brief window when the moon covers the sun completely, you might notice something strange and wonderful. The stars come out, not all at once, and not like night, but the brightest ones, the planets especially, which shine more steadily than stars, begin to appear in the darkened blue of the daytime sky. Venus is often visible during an eclipse, glowing to one side of the covered sun like a small, still lantern. Astronomers have used eclipse totality to spot planets and test calculations since ancient times. In 1919, a scientist named Arthur Eddington traveled to a small island off the west coast of Africa to observe a total solar eclipse. He was not there to admire the corona, though it must have been beautiful. He was there to test a very new, very strange idea proposed by Albert Einstein, that massive objects bend the fabric of space and time, and that starlight passing close to the sun should be shifted slightly from its expected position because of this bending. Eddington photographed stars near the sun during totality and found exactly what Einstein predicted. That expedition changed our understanding of the universe. It all happened in a few minutes of borrowed darkness during an eclipse. The path of totality, the narrow corridor on Earth's surface where the moon's shadow falls completely, is called the umbra. It is typically only about 100 to 200 kilometers wide. Outside this path, you see a partial eclipse where the moon covers only part of the sun. Inside the path, you experience something else entirely. The quality of light changes even before totality begins. It becomes thinner somehow, less golden. Colors look different, slightly flattened, slightly wrong, as if the saturation has been turned down by some invisible hand. Shadows grow strangely crisp. Animals begin to behave as though evening is coming. Bees, it has been observed, return to their hives when the sky darkens during an eclipse, just as they do at dusk. They sense the drop in light and temperature and begin the same routines they perform every evening. Then, a few minutes later, when the sun emerges and the light floods back, they pour out again in confusion, reorienting themselves to an unexpected morning. Birds have been seen roosting in trees during totality, settling into their sleeping positions and then, startled, taking flight again when the light returns. The world does not quite know what to make of an eclipse. The temperature can drop noticeably in the path of totality, sometimes by as much as 10 degrees Celsius within the span of a few minutes. This happens because the moon is blocking the sun's heat as well as its light. The air cools, and sometimes a gentle wind rises in response, moving from the cool shadow outward toward the warmer surrounding air. This wind has a name. It is called the eclipse wind, and people standing at the edge of the shadow have described feeling it pass over them like the breath of something enormous and slow. The speed of the moon's shadow as it races across the earth is astonishing. Depending on the geometry of the eclipse, the umbra can travel at anywhere from about 1,700 kilometers per hour near the equator to several thousand kilometers per hour at higher latitudes, where the Earth's surface curves away from the shadow more steeply. If you were somehow standing in space and watching, you would see a dark circle sliding swiftly across the lit surface of the Earth, like a slow blink. Ancient peoples who witnessed total eclipses had no way of knowing they were safe, that the darkness would end, that the sun would return. And yet, in many cultures, there are records of people who did not panic, who described what they saw with something close to reverence. The ancient Greeks observed that during a solar eclipse, stars appeared and animals fell silent. The Chinese court had astronomers whose job included predicting eclipses, so that the emperor could perform rituals to ensure the sun's return. In some traditions, the eclipse was understood as a dragon or a wolf swallowing the sun, and people made noise, beating drums, shouting, to frighten the creature away. And it always worked. the sun always came back. There is something deeply human about that response. The desire to do something, to participate, to not simply stand still in the face of something enormous and strange. And yet, there is also something to be said for the people who simply watched, who stood in the cooling air with their faces turned upward and let the darkness come over them, and felt, perhaps for the first time, just how small and how held they were by the world. The August 2026 eclipse will follow a path that begins over the Arctic, sweeps down through Greenland, crosses the Atlantic, passes over Iceland, arcs through northern Spain and the Balearic Islands, touches parts of the Mediterranean coast, and then continues across northern Africa. The Canary Islands will experience it. Parts of Morocco will go dark. The ancient city of Cordoba in Spain, a place that has stood since Roman times and watched centuries of history unfold, will find itself in the moon's shadow for several minutes in the middle of an August afternoon. People are already making plans, booking travel, setting out cameras and chairs in fields and on rooftops. Some of them will have waited their entire lives for this. There is something restful, if you let it in, about knowing this. About the fact that the universe runs on rhythms and cycles so precise that we can calculate them thousands of years in advance. The next total solar eclipse visible from Europe after 2026 won't happen for some years. These events are rare enough to feel like gifts, common enough to feel like a promise. The sky keeps its appointments, and if you can't be in the path of totality yourself, you can still lie here tonight in the soft dark and let the story of it wash over you like the light washes over the world every morning, without asking, without announcing itself, simply arriving. If this kind of story is what you like, slow, warm, full of the quiet wonders of the world, you might want to leave a comment below and let us know. It means more than you might think. And if you haven't already, there is a whole playlist of these stories waiting for you, one for every night. You need a gentle landing. There is a moment during a total solar eclipse that people who have seen it describe in almost identical terms, no matter where they were, no matter what language they speak. They call it the moment the shadow arrives. It comes from the west, moving faster than any weather. It does not creep the way a cloud creeps across the sun on an ordinary afternoon. It rushes. One observer described it as a purple darkness rolling across the hills like an enormous wave, soundless, swift, and then complete. In the seconds before totality, the light changes so quickly that the human eye can barely process it. And then the sun disappears, and where it was, something else stands in its place. What stands there is the corona, that soft, white, structured light that surrounds the hidden disk. No photograph has ever fully captured it, though many have tried. This is partly because the corona spans such an enormous range of brightness, from its faint outer reaches to its brighter inner ring, that no single camera setting can hold it all. And partly it is because the experience of seeing it is not only visual, it is the cold air and the hush and the planets in the daytime sky and the faint shadows that still fall at your feet and the sound, or the absence of sound, that makes it what it is. The corona changes from eclipse to eclipse. It shifts with the sun's activity cycle, which runs approximately 11 years from quiet minimum to active maximum and back again. Near solar minimum, when the sun's magnetic activity is low, the corona is relatively simple and symmetrical. Long streamers reaching out from the equatorial regions with shorter polar plumes above and below. Near solar maximum, the corona is more complex, more tangled, more alive-looking, with structures radiating in many directions. The 2026 eclipse falls near solar maximum, which means the corona may be particularly beautiful and intricate. The sun goes through these cycles because of its magnetic field, which is not fixed and simple the way Earth's magnetic field is. The sun is not a solid body. It rotates, but different parts rotate at different speeds. The equator completes a rotation in about 25 days, while the poles take closer to 35 days. This differential rotation gradually twists and tangles the magnetic field lines over the years, building up tension until the field becomes highly complex. Then, every few years, the whole field flips. The north magnetic pole becomes the south, and vice versa. This flip marks the midpoint of each solar cycle. During solar maximum, the sun produces more sunspots, cooler, darker regions on the surface caused by concentrated magnetic fields, and more solar flares and coronal mass ejections. A coronal mass ejection is a burst of plasma and magnetic field erupting from the sun's atmosphere, sometimes aimed toward Earth. When this plasma reaches us, it interacts with Earth's magnetic field and can produce the aurora, the northern and southern lights, visible at much lower latitudes than usual. So, a sun near maximum is a more dramatic, more eventful sun, and watching its corona during an eclipse at this time is like seeing the sun at its most expressive. The path of the moon's shadow is predictable because the motions of the Earth and Moon are governed by gravity, which is exquisitely consistent. Every total solar eclipse can be calculated with great precision both into the past and into the future. Astronomers have built detailed records called Saros catalogs, tracing eclipse families back thousands of years. The 2026 eclipse belongs to Saros 126, a series that began in the year 1179 and will continue until 2459. Each eclipse in a series is shifted slightly, about 120 degrees west in longitude from the previous one, because of the way the cycles align. The same shadow, the same family of shadow, has been crossing different parts of the Earth for centuries. One of the most touching things about these calculations is how they allow us to reach backward in time. Historians and archaeologists have used eclipse records to establish the dates of ancient events. In 585 BCE, a battle between the Medes and the Lydians was interrupted by a total solar eclipse so startling that both armies stopped fighting and made peace. Greek historian Herodotus recorded this, and because we can calculate when this eclipse occurred, we have a precise anchor date for a period of ancient history that would otherwise be poorly understood. The moon's shadow keeps its own kind of record. When the moon's shadow first touches the Earth at the beginning of an eclipse, it arrives at the point closest to the moon, typically somewhere in the polar regions or over the ocean, and then sweeps across the surface as the Earth rotates and the moon continues its orbit. The geometry is always slightly different. Sometimes totality lasts only a few seconds. Sometimes it stretches to 7 minutes and 32 seconds, which is the theoretical maximum. Most total eclipses offer 2 to 4 minutes of totality. For the 2026 eclipse passing over Spain and North Africa, totality in the best spots will last around 2.5 minutes, which sounds brief, which is brief. And yet people who have experienced it say those minutes feel like a different kind of time altogether. There is a phenomenon that occurs in the last seconds before totality that you can watch for, if you are ever fortunate enough to stand in the path. It is called Bailey's beads. As the moon's edge moves over the sun, the mountains and valleys along the moon's limb, its outer edge, create gaps that let the last tiny slivers of sunlight through. These appear as a string of bright dots along the moon's edge, like pearls on a dark thread. As the rest of the sun disappears, they shimmer for a moment, and then the last one vanishes. And then you are in totality. Right at the moment the last Bailey's bead disappears, there is often a brief, brilliant flash of light on one side of the moon's disk. This is called the diamond ring effect. It looks exactly as it sounds. A dark band with a single blazing point of light, surrounded by the soft glow of the inner corona. It lasts only a second or two. People gasp, some cry. It is sudden and quiet and absolutely overwhelming in the way that only very beautiful things can be. The moon, at this moment, is not entirely dark. It is lit from behind by earthshine, sunlight reflected off the earth back onto the moon's surface. This gives the lunar disk a very faint, ghostly gray color during totality. You can sometimes see the full circle of the moon hanging in the darkened sky, just barely visible, surrounded by the corona's pale fire, the lit ring of the corona and the barely visible disk within it. It is extraordinary. In the seconds after totality ends, the same sequence plays in reverse. Another diamond ring flash, another string of Bailey's beads, and then the sun reasserts itself, flooding back so quickly that observers often find themselves blinking, surprised by how sharp and immediate the return of the light is. The whole event, from first contact to last, lasts a couple of hours, but the totality, the heart of it, is over almost before you can understand what you have seen. And then you understand it slowly, in the hours and days and years afterward. Some people find that a total solar eclipse changes how they relate to the sky. Not in a mystical way, not necessarily, but in a quiet, practical way. They start noticing the moon more. They look up more often. They become aware of the sun as an object, a specific, finite, beautiful object, rather than simply the light that falls on things. There is something about witnessing its temporary disappearance that makes its presence feel more real, more particular, more worth attending to. There are people who follow eclipses. They are called umbrophiles, lovers of the shadow, and they travel enormous distances to stand in the path of totality as many times as they can. One dedicated observer reportedly saw his first eclipse and spent the next 4 decades chasing them around the world, from India to Australia to the middle of the Pacific, wherever the shadow fell. He described each one as completely different and completely itself, the way you might describe great music, always the same essential thing and always somehow new. What the umbrophiles understand, and what you can begin to understand simply by lying still tonight and thinking about it, is that the universe is not indifferent to you, not in a personal sense. The planets and stars are not arranging themselves for your benefit, but the rhythms of the solar system, the alignment of distances and sizes, the mathematics of gravity. All of these things have conspired to make Earth a place where a human being can stand in a field in August and watch the moon cover the sun and see a ring of fire bloom in the sky. This seems like a gift. You do not have to believe in anything particular to feel that it is. The shadow of the moon on the surface of the Earth, seen from space, looks like a dark spot moving across a lit globe. Astronauts on the International Space Station have photographed this. The shadow is surprisingly small, a circle only about 100 to 200 kilometers wide, drifting over oceans and mountains, cities and deserts, carrying its few minutes of borrowed twilight to whoever happens to be underneath. From that distance, you can see the whole arc of the shadow's path at once, the way you might trace a pencil line across a drawing. It is peaceful. It is just the moon doing what it always does, going where it always goes, casting its shadow, as it has for 4.5 billion years. Tonight, you don't need to be anywhere in particular. You don't need to have booked a flight or driven to a hilltop. You can simply be here in the warm dark, breathing softly, and letting the thought of that shadow pass over you gently, the way all good things do, arriving without fanfare, staying for just as long as they are meant to stay, and then moving on. Did you know that the Sleepy Science playlist has stories about oceans, northern lights, rainforests, and the deep history of the stars? Each one is made just for moments like this one. You can find them all together. And if you're enjoying this story, a like helps others find their way here too. Let's go a little deeper into the world that exists just below the surface of what we usually notice. The sun, which seems so fixed and constant from where we stand, is actually in constant motion, not just moving through space with our whole solar system, but rotating, churning, pulsing with magnetic activity in ways that take decades to fully unfold. The surface of the sun is not smooth. It is covered in granules, cells of rising hot gas, each one roughly the size of Texas, that bubble up from below, release their heat, cool, and sink back down, only to rise again. This convective cycle happens continuously across the entire surface of the sun. When you look at a photograph of the sun taken through a special telescope, the granulation makes it look almost like the skin of an orange, or the texture of a loaf of freshly baked bread, warm, alive, in motion. Within this bubbling surface, sunspots appear. They look dark in photographs because they are cooler than the surrounding plasma, about 3,500 degrees Celsius instead of 5,500. But in absolute terms, they are still blindingly bright. If you could somehow move a sunspot away from the sun and place it alone in the night sky, it would glow more brilliantly than the full moon. It only looks dark in contrast to the even brighter surface surrounding it. Sunspot activity was first documented carefully in the 17th century, and astronomers soon noticed that the number of sunspots on the sun's surface rises and falls in a rhythm of roughly 11 years. This solar cycle has continued without interruption for as long as we have been watching. We are currently in solar cycle 25, and its maximum, the peak of activity, is expected to occur right around the time of the 2026 eclipse, meaning the sun will be at its most magnetically complex and most dramatically beautiful when the moon moves across its face. The magnetic field of Earth protects us from the solar wind, the constant stream of charged particles flowing outward from the sun in all directions at speeds of 400 to 800 kilometers per second. Without this magnetic shield, the solar wind would gradually strip away the atmosphere, the way it appears to have stripped the atmosphere from Mars over billions of years. Mars once had a thicker atmosphere and liquid water on its surface. Its small size meant it cooled faster, its magnetic dynamo quieted, and then the solar wind slowly carved away what remained. Earth, larger and still magnetically active, has kept its warm blanket of air. The solar wind, though invisible, reaches all the way past Pluto. The region of space dominated by the solar wind, called the heliosphere, is vast, extending well beyond the outer planets. It is the sun's breath, in a sense, filling an enormous bubble of space with its influence. At the outer edge of the heliosphere, the solar wind finally slows and gives way to the interstellar medium, the thin gas and dust between the stars. Two human-made spacecraft, Voyager 1 and Voyager 2, have actually crossed this boundary and are now traveling through interstellar space, still sending back data, still communicating with Earth across unfathomable distances. The solar system itself moves through the Milky Way galaxy, orbiting the galactic center at a speed of about 220 kilometers per second. At this speed, one complete orbit of the galaxy takes about 225 million years. This period is sometimes called a galactic year or a cosmic year. In the time since life first appeared on Earth, our solar system has made roughly 17 complete orbits of the galaxy. The last time we were in this precise position in the galaxy, dinosaurs had not yet evolved. The sun that rose over those ancient seas was the same sun, burning in the same way, and yet the whole solar system was somewhere else entirely in the great wheeling structure of the Milky Way. The Milky Way contains somewhere between 200 and 400 billion stars, and it is just one of an estimated 2 trillion galaxies in the observable universe. When you lie beneath the night sky, or beneath the brief darkened sky of an eclipse, and you feel that sensation of the stars being enormously far and numerous beyond comprehension, you are not imagining anything. The scale is exactly as large as it feels, and yet you are here in a small corner of one galaxy on a precisely sized blue world orbited by a precisely sized moon at a precisely right distance from a well-behaved, middle-aged star, able to watch one of the most beautiful accidents of geometry in the known universe. That feels worth something. That feels like enough. Astronomers who study the deep history of our sun believe it is a third-generation star, one that formed from gas and dust enriched by previous generations of stars that lived, burned, and exploded before ours. The elements that make up the Earth, the iron in your blood, the calcium in your bones, the carbon in every living cell, were forged inside earlier stars and scattered into space by supernova explosions billions of years before the sun was born. This is not a metaphor. You are, in the most literal chemical sense, made of stardust. When you breathe in right now, slowly, the oxygen filling your lungs was made by ancient stars. The nitrogen mixed with it was shaped in the same cosmic furnaces. The water in your body contains hydrogen that is nearly as old as the universe itself, formed in the first few minutes after the Big Bang, and oxygen that was made much later in stellar cores. You carry the history of the universe inside you, rearranged by billions of years of chemistry and biology into the particular shape that is you, lying here, softly breathing, half asleep. There is something that often goes unspoken about total solar eclipses, something that you might only arrive at if you lie quietly and think about them long enough. It is not just that they are beautiful, though they are. It is not just that they are rare, though they are. It is that they are, in a very real sense, temporary. As the centuries pass, the moon is very slowly moving away from Earth at a rate of about 3.8 centimeters per year. This sounds trivial, but over millions of years, it adds up. The moon is gradually getting farther away, which means it will eventually appear too small in the sky to cover the sun completely. Total solar eclipses as a phenomenon have a limited run. They will end eventually in geological time. The ones we can see now are available only because we exist at precisely the right moment in Earth's history when the moon's apparent size matches the sun's. What extraordinary timing! In about 600 million years, the last total solar eclipse will occur. After that, the moon will be too far away to fully cover the sun. What will remain are annular eclipses, the kind where the moon covers the center of the sun, but leaves a bright ring of light around its edge, which is beautiful in its own right, but not the same. The corona will never again be visible to naked eyes from Earth's surface. The diamond ring will never again appear. The shadow will still fall, but the totality will be gone. This will happen in the lifetime of Earth, though not in the lifetime of any living thing that currently walks on it. Knowing this makes the 2026 eclipse feel like something to hold gently, not with urgency, not with grief, but with appreciation. We are here at the right time. The moon is the right distance. The sun is the right size. And somewhere in August of next year, people will stand in a field or on a hilltop, and the sky will darken around them, and the corona will bloom, and they will feel, very likely, that they have been given something. After an eclipse, many people describe a kind of gentle sadness as the light returns. Not a distressing sadness, more like the feeling at the end of something beautiful, the closing of a piece of music, the last page of a book you did not want to finish, the return of ordinary daylight, which was perfectly nice before, feels somehow bright and busy and a little loud. People often stand quietly for a while, even after the sun is fully returned, not quite ready to re-enter the ordinary world. This too is part of the experience. Sleep researchers have found that our sense of what is ordinary and what is remarkable is closely tied to contrast. We notice the quiet more when there has been noise. We appreciate warmth more after cold. The beauty of the returning sun after a few minutes of its absence is enhanced precisely because of the absence. This is perhaps why people who have seen total eclipses so often describe them as among the most beautiful things they have ever witnessed. The contrast is built into the experience. The darkness makes the light. You can feel a very small version of this right now if you like. Simply close your eyes for a moment, not to sleep yet, just to feel the darkness. And notice how soft it is. Notice that it is not frightening, not empty. It has a quality of its own, a texture, a warmth behind the lids. And when you open them again, even the dim light of wherever you are will have a slight glow to it that it did not have before. This is how the eclipse works. This is how most beautiful things work. They teach you to notice what was already there. Let's keep moving gently through this story. There is so much more to the sun, to the moon, to the delicate dance between them that creates these moments of borrowed darkness. You are in no hurry. Let your breath slow. Let the words come to you like light from a distant place, already on their way, arriving at exactly the right time. If you'd like to share what you think about this story, or tell us what topic you'd love to hear about next, the comments are always open. We read them, and they shape what we make. You're part of this channel too. One of the things that makes eclipses so moving is how they remind us that the sky is not a backdrop. It is not scenery painted on a flat wall behind the real world. It is the real world, vast, moving, governed by forces that are entirely indifferent to human schedules, and yet somehow keep their appointments with extraordinary precision. The word eclipse comes from the ancient Greek word ekleipsis, which means abandonment or a failing, a ceasing to exist. The sun fails for a moment, and then it does not. There is something philosophically interesting in this. The oldest human word for this event carries inside it the idea of absence, of something missing. The ancient Greeks experienced eclipses as their civilization was coming into one of its great flourishings, when mathematics and astronomy and philosophy were beginning to shape the way humans understood themselves in the world. Thales of Miletus, one of the first Greek philosophers, is credited with predicting a solar eclipse in the 6th century BCE, the same one that stopped the battle between the Medes and the Lydians. How he managed this prediction is not entirely known. He may have learned techniques from Babylonian astronomers who had centuries of careful eclipse records and had noticed the repeating cycle, the Saros, that governs when eclipses occur. The Saros cycle lasts about 18 years and 11 days, and after one complete Saros, the sun, moon, and earth return to almost exactly the same relative positions, producing a very similar eclipse. Babylonian astronomers were meticulous record keepers, and their tables of lunar and solar motion were detailed enough that patterns began to emerge over generations of observation. Imagine being one of those ancient astronomers. You sit in the cool night air, making careful marks on clay tablets. You watch the moon rise. You note its position against the stars, which do not move relative to each other night after night. You do this for years. Your teacher did it for years before you, their teacher before them. And slowly, across all those accumulated observations, something emerges, a pattern, a rhythm, a way that the movements repeat. And then, one day, you're able to say to the king, in 18 years and 11 days, the sun will go dark. And it will go dark, and you will have been right, and something in the universe will have yielded just slightly to the patient attention of a human being with a clay tablet and a clear sky. This is one of the things that moves me most about the long human relationship with eclipses. It is a story of patience rewarded. The sky does not give up its patterns quickly. You have to watch for a long time. You have to trust that there is a pattern to find. And eventually, after years, after decades, across generations, the rhythm makes itself known. The universe does not hide its secrets. It simply requires patience and attention and a willingness to keep looking, even when what you are looking for is not yet visible. In medieval Europe, Total solar eclipses were often recorded in monastic chronicles, the careful day-by-day records kept by monks who observed the world around them with a spirit that was both religious and scientific, or rather, who had not yet made a distinction between the two. These records describe the darkness of midday, the appearance of stars, the strange behavior of birds. They are written in a tone of awe that is also a tone of acceptance. Extraordinary things happen, and they should be noted, and they fit within a world that is both wondrous and ordered. In the Islamic world during the same centuries, astronomers were making some of the most precise measurements of the sky yet attempted. They built observatories with enormous instruments, large enough that their scale reduced the error in each measurement. They refined the calculations of the moon's motion to extraordinary precision. The word algebra comes from Arabic. So do the words zenith, nadir, azimuth, all the words for parts of the sky that navigators and astronomers needed names for. The rich tradition of Islamic astronomy preserved and extended the knowledge of the ancient world, while Europe was between intellectual phases, and eventually that knowledge flowed back westward and became part of the foundation of the scientific revolution. So, when the moon's shadow falls across Spain in August of 2026, it falls on a landscape that has been watching the sky for a very long time. The city of Toledo, which lies near the eclipse path, was a center of astronomical translation in the 12th century, where scholars translated Arabic and Greek texts into Latin and made them available to European thinkers. The stars have been named and renamed in that sky. Eclipses have been watched from those hills for more than 2,000 years. The shadow that passes will not be seen by anyone who could not, if they looked, stand in a long, unbroken line of sky watchers reaching back through time. The light that the moon blocks during a total solar eclipse is almost immediately replaced by the light of the corona. So the path of totality is not true darkness. It is a very deep twilight, a blue-gray dusk that falls in the middle of the day. The horizon in all directions glows with an orange and pink light, because you can see the edge of the shadow from within it. The distant sunlit world rings the shadow like a sunset on all sides at once. People standing in totality can look outward in any direction and see this sunset ring encircling them, while directly overhead the corona blooms in a darkened sky. It is unlike any other visual experience on Earth. Photographers who try to capture this describe the challenge as almost mathematical. The range of brightness, from the dark disk of the moon at the center to the faint outer corona, down to the orange horizon glow, exceeds what any camera sensor can record in a single exposure. To capture the full experience, photographers typically take rapid sequences of images at many different exposure settings and blend them afterward. Even then, they say, it does not look like what they saw. The eye is more sensitive, more adaptive, more capable of holding the whole experience at once. No image quite contains it. There is a lesson in this that goes beyond photography. Some experiences are not fully transferable. They require presence, actual, physical, embodied presence, standing in a field or on a roof or at the edge of the sea, feeling the air cool, hearing the birds go quiet, watching the light thin. This is not a criticism of photographs or recordings or stories. All of these things have real value. but they are invitations to the experience, not substitutes for it. The story of a total eclipse, however well told, is an arrow pointing toward something that words can only approach. The thing itself is in the sky. For those who cannot travel to the path of totality, a partial eclipse is still something. You will see the moon take a bite from the sun and grow, and the light will change, becoming slightly flat and shadowless in a way that is hard to explain, but quite noticeable once you know to look for it. Shadows through tree leaves, you can try this yourself, create tiny pinhole projections of the sun's changing shape on the ground, like hundreds of small crescent moons scattered in the shade. This is a phenomenon caused by the gaps between leaves, acting as natural pinhole cameras. You can watch the eclipse through the shadows without ever looking directly at the sun. And speaking of that, during totality, and only during totality, it is safe to look directly at the eclipsed sun with the naked eye. The moon covers the brilliant photosphere completely, and the corona, though beautiful, does not produce enough light to harm your eyes. But the moment the sun begins to reappear, the moment the first sliver of the photosphere becomes visible, you must look away. The sun reasserts itself very quickly, and unprotected eyes can be damaged in seconds. Eclipse glasses, special filters much darker than ordinary sunglasses, allow safe viewing during the partial phases. For totality, no glasses are needed, and in that moment, looking without any filter at the corona and the dark moon and the diamond ring, that direct, unmediated experience of something real and enormous happening in the sky is the whole point. The story of the total solar eclipse is also the story of how we learn to see the universe, not just to look at it, but to understand what we were looking at. This is a long story, still being written, and tonight we are simply following one thread of it, the thread of the moon's shadow, as it winds through human history and into the bright, darkening August sky of 2026. Before we go further, a small reminder. If you're new here, our playlist is full of nights like this one. There's one about deep ocean currents, one about the northern lights, one about the way trees communicate underground. Each one is made to carry you gently toward sleep. They're waiting for you whenever you need them. The geometry of a total solar eclipse is surprisingly delicate. The moon must be close enough in its orbit to appear large enough to cover the sun, which means the eclipse must occur near perigee, the moon's closest point to Earth. The moon must be at the right phase, new moon, when the moon is between the Earth and the sun. And the moon must be crossing the ecliptic, the plane of Earth's orbit around the sun, at just the right moment, because the moon's orbit is tilted about 5 degrees relative to the ecliptic, which is why we don't have a solar eclipse every month. Usually at new moon, the moon passes slightly above or slightly below the sun in the sky, and no eclipse occurs. When all of these conditions align, the right distance, the right phase, the right position relative to the ecliptic, an eclipse happens. The narrow window of opportunity is defined by what astronomers call the eclipse limit, a zone of about 15 to 18 degrees on either side of the lunar node, where the moon crosses the ecliptic. If the new moon occurs within this zone, an eclipse of some kind will happen. If the moon is also near perigee, the eclipse can be total. The moon's nodes, the 2 points where its orbit crosses the ecliptic, moves slowly backward along the ecliptic, completing a full cycle in about 18.6 years. This is called the regression of the nodes, and it is the reason the Saros cycle works the way it does. After 18 years and 11 days, the Moon, Earth, and Sun have all returned to almost exactly the same relative positions, including the position of the nodes. The eclipse that follows is very similar to the one 18 years earlier. Similar path, similar duration, similar appearance. The 2026 eclipse is the younger sibling of an eclipse that crossed a similar region in 2008. Thinking about the Saros cycle is like hearing a very long piece of music that repeats with small variations. Each eclipse in a series begins near one of Earth's poles, then slowly shifts over many centuries toward the equator, producing gradually longer totality durations as it does so. Eventually, the eclipse path moves toward the opposite pole, and the series ends, the last eclipse just barely grazing Earth before the shadow misses entirely, and the cycle is complete. The whole sequence from first to last takes about 1,200 to 1,300 years. The 2026 eclipse sits in the middle of Saros 126's life, a series that is mature but not yet old. The Moon itself, as we stand beneath the eclipse watching it cover the Sun, is traveling through space at about 1 kilometer per second in its orbit around Earth. Earth is simultaneously moving around the Sun at about 30 kilometers per second. The Sun, with everything orbiting it, is moving around the galactic center at 220 kilometers per second. And the entire Milky Way is moving through the local group of galaxies toward the Andromeda Galaxy at about 110 kilometers per second. Everything is in motion, always. The stillness we feel beneath the eclipse sky is the stillness of our own perspective, not the stillness of the universe. We are moving in all these directions simultaneously, carried along without sensation, the way you feel no movement on a smooth flight high above the clouds. The surface of the Moon is ancient and still, without an atmosphere, without water, without tectonic activity. The Moon's surface has changed very little for billions of years. The craters you can see with a good pair of binoculars on a clear night are impact scars from early in the solar system's history, when the inner solar system was bombarded with debris left over from the formation of the planets. Some of these craters are billions of years old. The lunar highlands, the pale, heavily cratered regions visible to the naked eye, are older than the darker plains, called Maria, which were later flooded by ancient volcanic eruptions and then solidified. The Maria, whose individual patches have been given poetic names, the Sea of Tranquility, the Ocean of Storms, the Sea of Serenity, are not actually seas. There has never been liquid water on the Moon's surface, but they look smooth and dark from Earth, and early astronomers imagined they might be oceans. The name has persisted even as the reality became clear. The Sea of Tranquility, Mare Tranquillitatis, is where Apollo 11 landed in 1969, where Neil Armstrong and Buzz Aldrin walked on the ancient, dust-covered volcanic plain. The footprints they left there are still there. The Moon has no wind, no rain, no erosion. Those footprints will remain for millions of years unless a meteorite disturbs them. There is something quietly moving about this, that two humans walked on a plain of ancient lava that formed 3.5 billion years ago, left footprints in its dust, and those footprints will outlast our civilization. They will still be there when the next total solar eclipse crosses Spain and North Africa in whatever century comes after the last. They will be there when no one remains who knows they were made. The dust on the moon is not like ordinary dust. It is called regolith, and it has a very unusual texture. Sharp, angular, and clingy in a way that regular dust is not. On Earth, dust particles are tumbled and rounded by wind and water over time, the way pebbles become smooth in a riverbed. On the moon, there is no tumbling. The regolith is made from the micro-impacts of cosmic rays and tiny meteorites over billions of years, and each particle has sharp edges that catch and hold the light, and catch and hold each other. The astronauts found it clung to their suits, their equipment, everything. It smelled, they said, when brought into the lunar module, like burnt gunpowder. The ancient dust of the moon has its own particular quality, shaped by the same airless, waterless, still conditions that make the footprints last. The moon's influence on Earth is enormous, even beyond eclipses. The tides, the daily rise and fall of the oceans, are driven primarily by the moon's gravitational pull. The moon tugs on the side of Earth facing it, stretching the ocean slightly toward it, and the ocean on the far side bulges outward too, due to the mechanics of rotating systems. This creates 2 high tides and 2 low tides in most places every day. The tidal forces from the moon also slow Earth's rotation very gradually. Days are getting longer by about 1.4 milliseconds per century. 4.5 billion years ago, a day on Earth was only about 6 hours long. The moon stabilizes Earth's axial tilt. Earth is tilted about 23.5 degrees relative to its orbital plane around the sun. This is what gives us our seasons. Without the moon's stabilizing gravitational influence, calculations suggest that Earth's axial tilt could wander dramatically over geological time, swinging from near zero to over 80 degrees. This would produce catastrophic climate swings, long periods where the poles faced the sun directly, and then long periods where they faced away. Life as we know it might not have been able to establish itself and persist in such conditions. The moon, it seems, is not just beautiful. It may be one of the reasons we are here at all. Let your thoughts drift now, the way the moon's shadow drifts across the Earth, slowly, silently, covering everything it touches in a brief and gentle dark. You have been lying still long enough that your body has begun to settle, the way water settles when you stop stirring it. The story is still here. There is no hurry. We have talked about the moon's pull on the oceans, but the moon also pulls, ever so slightly, on everything else. On the land itself, which rises and falls by small amounts with each tidal cycle. This is called earth tides. And in some places, the solid ground rises and falls by as much as half a meter twice a day. This is not something you would ever feel, but it is measurable with very precise instruments. The Earth is breathing very slowly in time with the moon. The gravitational pull of the moon extends throughout the solar system, as do the gravitational pulls of all the planets, though they weaken with distance according to the inverse square law. Double the distance, and gravity falls to 1/4 of its original strength. The gravitational landscape of the solar system is enormously complex, with every body pulling on every other body all the time. The mathematics of this, called the n-body problem, where n represents the number of objects, is so complex that for 3 or more bodies, no exact general solution exists. We calculate the motions of the planets using numerical integration, computing billions of tiny steps forward in time. The answer is approximate, extremely precise, and constantly being refined. Despite this complexity, the solar system is remarkably stable. The planets have remained in roughly their current orbits for billions of years, held in a kind of dynamic equilibrium by the same gravitational forces that pull on them. There are small, slow variations, orbital resonances, the slight wobble of Earth's axial tilt, the very gradual change in Earth's orbital eccentricity. But these unfold over timescales of tens of thousands to hundreds of thousands of years. On human timescales, the solar system is essentially fixed. The sun rises and sets, the moon waxes and wanes. The planets follow their courses through the constellations. The eclipses come. The word planet comes from the Greek word for wanderer, planets, because unlike the fixed stars, which maintain their positions relative to each other, the planets move. Ancient sky watchers noticed 5 wanderers visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. They moved slowly but perceptibly against the background of fixed stars, tracing paths through the sky across weeks and months. The patterns of their movement were studied intensely because understanding where they would be seemed important for agriculture, for navigation, for the calendar, for divination. The motion of the planets was one of the deepest puzzles in all of early science. The most successful model for many centuries was the one proposed by the Greek astronomer Ptolemy in the 2nd century CE, a complex system of circles within circles called epicycles that could predict planetary positions with reasonable accuracy. It placed Earth at the center of everything, which seemed obvious and natural. And then, in the 16th century, Nicolaus Copernicus proposed putting the sun at the center instead, and the whole picture became dramatically simpler. Not immediately accepted, the idea met resistance and took generations to fully take hold. But eventually, through the work of Kepler, who found the mathematical laws governing planetary orbits, and Galileo, who turned his telescope toward the sky, and Newton, who found the gravitational law that explained why those orbits had the shapes they did, the sun-centered picture settled into place. What is remarkable is that all of this understanding, all of this centuries-long unfolding of how the solar system actually works, has made the eclipse more wonderful, not less. Knowing that the moon's apparent size matching the sun's apparent size is a coincidence, not a design, makes it stranger. Knowing that this coincidence will eventually end as the moon drifts farther away makes it more precious. Knowing that the corona is a super hot atmosphere whose origin is still partly mysterious, that the prominences are loops of plasma guided by magnetic fields, that the diamond ring is simply the geometry of light and shadow. Knowing all of this adds layers to what you see, turns it from a beautiful image into a beautiful story. This is what this Sleepy Science channel is about, really. Not just facts, though the facts are wonderful, but the way facts open out into something larger, the way each piece of knowledge, absorbed slowly and gently, becomes part of how you see the world. The way a fact about the moon's recession from Earth can make an August afternoon in Spain feel like something rare and worth attending to. The way knowing that the corona's heat is still partially mysterious can make you feel accompanied by all the other people, past and future, who have looked at the same sun and wondered about the same thing. There are approximately 239,000 total solar eclipses in the history of Earth, from the formation of the moon to the end of total eclipses. If we assume the moon gradually moves away at its current rate, and the phenomenon ends in about 600 million years. Of all those eclipses, humans have been present to observe perhaps tens of thousands. Of those, a very small fraction were observed by people with the tools and knowledge to understand what they were seeing. We exist at a rare and fortunate point, evolved enough to understand the physics, advanced enough to predict and travel to the path, and still early enough in the moon's slow retreat that total eclipses are still possible. You might fall asleep before this story ends, and that is perfectly fine. That is what the story is for. But carry something with you into sleep if you can. The image of a shadow moving across a sunlit world. A circle of darkness 100 kilometers wide, moving faster than any storm, carrying its few minutes of twilight across mountains and coastlines and ancient cities. And in that shadow, for just a minute or two, a ring of white light in a darkened sky, and stars in the afternoon, and the air cool and still, and people with their faces turned upward, breathing slowly, the way you are breathing now. If you've made it this far in the story, you know what it feels like to let your thoughts slow down and widen into something large and quiet. That's exactly what this channel is for. Leave us a comment. We'd love to know you're here. And if someone you care about could use a gentle night like this, share this story with them. The sun will set tonight, as it sets every night, and rise again tomorrow, as it always does. There is a comfort in this that goes beyond habit. The regularity of the sun's rising and setting is one of the most reliable rhythms in all of human experience. So reliable that we use it to measure time, to organize our days, to orient ourselves in the world. Before clocks, before calendars, the sun told us everything we needed to know about when things should happen. Plant in spring, harvest in autumn, rest when it is dark, rise when it is light. The sun rises in the east and sets in the west because Earth rotates toward the east. If you were watching from far above the North Pole, you would see Earth spinning counterclockwise, and the sun appearing to move from left to right across the sky as the planet turns you toward it and then away. This eastward rotation also explains why time zones progress eastward. As Earth turns, each longitude to the east arrives at local noon slightly earlier. The sky is not black during the day because of something called Rayleigh scattering. Sunlight, which contains all the colors of the rainbow, enters Earth's atmosphere and bounces off tiny molecules of nitrogen and oxygen. Short wavelength light, blue, scatters much more than longer wavelengths like red and orange. So the blue light bounces all over the sky, reaching your eyes from all directions, making the whole sky appear blue. Red and orange wavelengths travel through more directly, which is why sunsets and sunrises, when the light travels through the more atmosphere at a low angle, appear in warm colors, and why the skin of the eclipsed horizon during totality glows with that gentle ring of sunset orange. You are seeing the part of the sky where the light still arrives at a low angle, while directly overhead, The moon has removed the direct disk, and the sky has darkened. At very high altitudes, above most of the atmosphere, the sky is not blue at all. Astronauts on the International Space Station see the sun as a brilliant white object against a black sky, because without enough atmosphere to scatter the blue light, it goes straight outward into space without filling the sky around it. The brilliant blue of Earth's sky is an atmospheric phenomenon, a gift of the particular density and composition of the blanket of gas we live in. The atmosphere of Earth is about 78% nitrogen, 21% oxygen, and about 1% argon, with small amounts of carbon dioxide, water vapor, and other gases. The oxygen that makes up that 21% was almost entirely produced by living organisms, first by ancient bacteria called cyanobacteria, which began pumping oxygen into the early atmosphere about 2.7 billion years ago, and then by the photosynthesis of plants and algae ever since. Before life, Earth's atmosphere contained very little free oxygen. We breathe air that life made. The sky is blue because of a thin layer of gas whose composition was shaped by billions of years of living things. Carbon dioxide, though a small fraction of the atmosphere, plays an outsized role in regulating temperature. It is a greenhouse gas. It allows shortwave sunlight to pass through, but absorbs the longer wave infrared radiation that Earth radiates back towards space, trapping heat in the lower atmosphere the way a glass greenhouse traps warmth. This greenhouse effect is natural and necessary. Without it, Earth's average temperature would be about minus 18 degrees Celsius instead of the current plus 15. We would be frozen, but adding more greenhouse gases intensifies the effect, warming the atmosphere. This is the physics behind climate change, and it is the same physics that makes Venus, which has a very thick atmosphere of carbon dioxide, the hottest planet in the solar system, despite being farther from the sun than Mercury. The atmosphere is also what makes the sky change color through the day, what makes twilight exist. Without an atmosphere, the transition from day to night would be instantaneous, one step from full sun to full dark, the way it is on the moon. There is no dusk on the moon, no soft lengthening of shadows, no orange warmth gathering in the west, no gradual dimming that tells you evening is coming. The moon's sky is always either brilliantly lit or completely black, depending on which side of the mountain or crater wall you are standing on. Earth's atmosphere softens everything, spreads the light, diffuses the transitions. Even the coming of dark is gentle here. Twilight on Earth is not one thing, but three. Civil twilight, when the sun is just below the horizon and the light is still enough to see clearly. Nautical twilight, when the horizon is just barely visible and the brightest stars appear. And astronomical twilight, when the sky is dark enough for faint stars and the horizon has disappeared into the dark. Astronomers begin their observations in astronomical twilight, when the sky is just dark enough to be useful. The whole sequence from sunset to true astronomical night takes about an hour and a half at mid-latitudes, and then the night is complete and the stars are fully out, and somewhere among them, moving too slowly to notice, is the moon, doing its patient circuit of the sky, waiting for the moment when its shadow and the sun's disk will align. That moment will come in August of 2026, and then it will pass. And then it will be over, and the ordinary light will return, and the birds will settle back to what they were doing, and the bees will spill out of their hives in confusion, and the people in the path of totality will stand very still for a while, with their faces still pointed at the sky, not quite ready to look away. And you, wherever you are, whatever is outside your window, are also under the same sky. The same moon is up there, doing its slow, reliable circuit. The same sun is somewhere below your horizon or above it, making the same light it has always made. You are connected to everyone who has ever watched an eclipse, everyone who has ever noticed the sky go strange and held their breath, everyone who has ever felt small and held and lucky all at once. Let your eyes close now if they want to. The story will still be here. The sky will still be turning. The moon is crossing somewhere overhead, its shadow missing us tonight by just a few degrees, patient and steady and keeping its own quiet time. There is a quality to the world in the last few minutes before a total solar eclipse that observers describe as a kind of heightened attention, as if the world itself is paying closer notice. Colors become more vivid just before they change. Sounds seem cleaner. The air has a particular coolness and freshness that may be partly real and partly the effect of everything around you going quiet. Animals sense the change in light and temperature before humans typically do. Research conducted during various eclipse events has shown that chimpanzees in safari parks moved toward sleeping areas. Flamingos began to flock and move as if disturbed. Orb-weaving spiders, which normally build their webs at dusk, began their spinning in the premature darkness, and then had to stop and reverse when the light returned. Dairy cows have been observed heading toward their barns. Horses have been seen moving into their stables. The eclipse does not deceive every animal equally. Some seem to understand more quickly that something unusual is happening. But the initial response of many is simply to follow the script they know, the one that says when the light fades, it is time for rest. There is something tender about this, the birds settling into their nighttime positions, the spiders beginning their web building, the cows moving toward the barn, all of them trusting the old rhythms, the reliable patterns, the body knowledge that says this kind of light means evening. They are not wrong exactly. The light is genuinely lower. The temperature is genuinely dropping. It is just that it will not last. In a few minutes, the light will return, and they will have to readjust. And they will, quietly and without complaint, the way animals do. There is a lesson in this that is available if you want it, though you are not required to take it. Something about trusting the rhythms you know. Something about being willing to begin your evening routines when the light says so, even if you're not quite sure why the light has changed. Something about the usefulness of a body that knows what to do. Your own body knows what to do right now. It knows how to slow down. It knows the sequence of dimming, settling, releasing. The light is low where you are. The temperature is comfortable. The sounds around you are distant and soft. Your body has been doing this, preparing for sleep, for as long as you have been alive, and for all of evolutionary history before that. You do not have to figure it out. You simply have to stop stopping it. The sun, from 150 million kilometers away, still affects the rhythm of your body. The light that enters your eyes, particularly the blue wavelength light that comes from screens and overhead lights, signals to your brain that it is daytime, suppressing the production of melatonin, the hormone that initiates sleep. As light levels drop and blue wavelengths diminish, melatonin rises and the chemistry of sleep begins. Your body is, in this very precise way, calibrated to the sun. It runs on solar time. It always has. The circadian rhythm, the roughly 24-hour internal clock that governs not just sleep, but also hormone production, body temperature, digestion, and many other bodily functions, is kept roughly accurate by exposure to natural light. Without any time cues at all, in completely unchanging light conditions, the human circadian rhythm drifts slightly, running on a cycle of about 24.2 hours rather than exactly 24. Light exposure each morning resets the clock, synchronizing it with the actual rotation of the Earth. We are light-seeking creatures, calibrated to a planet, tuned to a star. In the same way that your body is calibrated to the sun, the moon's rhythms have also influenced life on Earth, though more subtly. Many marine organisms reproduce in synchrony with the lunar cycle, corals spawning, certain fish breeding, crabs releasing their eggs, all timed to the predictable rise and fall of the tides. The timing of tides varies with the phase of the moon, and the predictability of that pattern has allowed life in tidal zones to evolve extremely precise internal clocks that match the moon's cycle. Some of these organisms maintain their lunar rhythms even in laboratory conditions with no tidal cues. The moon's time is inside them, the way the sun's time is inside you. The gravitational influence of the moon extends even to the fluid in your body, though the effect is infinitesimally small, smaller than the gravitational influence of nearby objects, like a car parked outside your house. The idea that the moon influences human mood or behavior through gravity is not scientifically supported, but the moon's influence on the tides and the tide's influence on coastal life and the organisms that depend on predictable rhythms is very real and very beautiful. The moon shapes the sea shapes the coast shapes what can live there. The moon is, in this indirect way, woven into the whole story of coastal life on Earth. The tides are also responsible for something extraordinary that happens to rocky coastlines over geological time. The pounding of waves, shaped by the tides, gradually erodes and shapes the rock, creating caves, arches, sea stacks, and the particular forms of worn stone that make coastlines beautiful. The sea stacks off the coast of Scotland, the chalk cliffs of the English Channel, the dramatic rock formations of the Atlantic coast of Portugal. All of these are the moon's handiwork, translated through water and time into stone. When you walk on a beach, if you are lucky enough to do so, you are walking on rock that the sea has been working on for thousands or millions of years, shaped in part by the tidal forces generated by the moon. The sand between your toes, if it is derived from rock, as most sand is the end product of this patient, endless work. The moon has been making sand in this indirect way for as long as it has been raising tides. The thought of all this slow, gentle work, water moving over rock, day after day, tide after tide, century after century, making sand, is one of the most restful thoughts available to a human mind. It requires nothing of you. It continues without your attention. It will continue long after you are gone. The tides will still be pulling. The waves will still be arriving. The rock will still be softening into sand, and the moon will still be up there, very slightly farther away than it was today, doing what it has always done. You are doing beautifully. Let the thoughts drift now. Let one image replace the last without trying to hold any of them. The spider beginning its web in the premature darkness, the horses moving toward their barn, the bees coming home, the sea making sand from rock, the moon turning in its patient orbit, each one a small, complete thing, connected to all the others by gravity and light and time. In the hours after a total solar eclipse, the world makes its recovery quietly. The birds that settled into roosting positions take to the air again, initially cautiously, and then with increasing confidence as the light reasserts itself. The bees that return to their hives stream out again into the warming afternoon. The spiders that began their webs may finish them or may not. Research has shown variable responses, some completing what they started, some abandoning the half-built web in the confusion of the returning light. The temperature rises quickly once the moon's shadow passes. The eclipse wind, which blew inward toward the cooler shadow, reverses or fades. The shadows sharpen back to their ordinary crispness. The sky returns to its deep blue, the quality of light, that strange, flattened quality that precedes totality, lifts, and ordinary yellow sunlight settles back into everything. The world becomes itself again. And yet, something has changed for the people who watched, something quiet and permanent. There is a documented phenomenon among eclipse chasers, people who travel repeatedly to stand in the path of totality, of becoming more comfortable with the natural world, more attuned to its rhythms, more willing to stand still and simply observe. Whether the eclipse causes this, or whether people who already have these qualities are more likely to seek out eclipses, is difficult to say. Probably both. But there is something in the act of traveling enormous distances, setting up in an open field, and giving 2 minutes of your complete and undivided attention to the sky that seems to reinforce a particular quality of presence, of being exactly where you are. This quality, presence, attention, the willingness to simply be somewhere without doing anything, is genuinely restful. The nervous system settles when attention is given to something slow and large and beyond personal concern. This is partly why nature sounds and slow music and stories like this one are helpful for sleep. They offer a place for the mind to rest that is outside the loop of personal thoughts and worries and plans. The sky is not thinking about your to-do list. The moon does not know your name. And somehow, attending to things that are indifferent to your particular concerns is soothing rather than cold. It puts your particular concerns into a scale where they are visible for what they are, real but small, in the context of an enormous and beautiful universe. The moon has been a companion to human sleep since the first humans lay down under the open sky. Before electric light, the moon was a significant source of illumination at night, and communities organized around its cycles in practical ways. The full moon was a time when outdoor work was possible into the evening, when travel by night was safer, when gathering and socializing could happen under the free light of the sky. The new moon, when the moon was absent from the night sky, was the darkest time, the quietest, the most inward. Many of the world's oldest calendars are lunar calendars, measuring months by the cycle of the moon's phases rather than the Earth's orbit around the sun. The Hebrew calendar, the Islamic calendar, the Hindu calendar, the Chinese calendar, all either lunar or lunisolar, tracking the moon's 29.5-day cycle. The word month comes from moon. The word menstruation comes from the Latin for month, mensis, which also derives from the moon. The moon's cycle is built into the language with which we measure time. A single lunar cycle, from new moon to new moon, is called a synodic month, and it lasts about 29 days, 12 hours, 44 minutes. This is slightly longer than the moon's actual orbital period of 27.3 days, because the Earth is also moving around the sun. So, after the moon completes one orbit, it has to travel a little farther to catch up to the same position relative to the sun and the same phase. The synodic month is what you experience when you watch the moon change night after night. The crescent growing, the half moon rising, the full moon blooming, then diminishing again. Watching the full moon is one of the oldest and most universal human pleasures. Societies around the world have held festivals, ceremonies, and celebrations timed to the full moon for as long as records exist. The Buddhist festival of Vesak, celebrating the birth and enlightenment of the Buddha, falls on the full moon of May. The Jewish festival of Passover begins on the full moon of Nisan. Easter is calculated as the first Sunday after the first full moon after the spring equinox. Diwali, the Hindu festival of lights, falls in the dark of the moon, the new moon of October or November. Even celebrations that are not religious often cluster around the full moon, because that is when the night is brightest, when outdoor celebration is most naturally possible. Tonight's moon, whatever phase it is in as you lie here, is the same moon that lit every one of those celebrations. The same moon that Galileo turned his telescope toward in 1609 and sketched with extraordinary care. The same moon that Apollo astronauts stood upon, looking back at a blue and white Earth floating in black space. The same moon that the August 2026 eclipse will be made of as it passes across the face of the sun in a path of borrowed darkness over Spain and North Africa and the warm Mediterranean Sea. If you have a window near you, and if the moon is visible tonight, you might take one last look before you close your eyes. You don't have to, but if it is there, it is worth a moment. Just the fact of it. That gray, ancient, beautiful circle hanging in the sky, moving silently, keeping its own time, pulling the tides, having been there since the beginning of everything you know. One moon, one sun, one fragile, lucky blue world between them. We are nearly at the end of this story now. The eclipse has passed over its mountains and its coastlines and its ancient cities, and the ordinary afternoon has returned. And people are still standing in their fields with their faces tilted up, not quite ready to look down. And here you are, lying still, breathing slowly, the story settling into you the way warmth settles. If this found you at the right moment, if it helped, please do tell us. A comment, a like, a quiet note in the middle of the night. They mean everything. And check the playlist. There are more nights like this one waiting for you, about the deep ocean, about mountains, about the way rivers find the sea. One for every night. You need a gentle place to land. The light is always coming back. That is the promise the eclipse makes and keeps every time. The shadow arrives, and it is extraordinary, and then it passes, and the light returns. This is not a metaphor exactly. It is just what happens. The physics are clear, and the geometry is reliable, and the light always comes back. And yet, if it feels like a metaphor, if lying here in the quiet dark, breathing slowly, letting the story settle into you, you find yourself thinking of other things that have passed and other lights that have returned. That is allowed. That is what the long human relationship with the sky has always offered. A place to put the things that are hard to put elsewhere. The sky is large enough to hold them without burdening itself. The corona blooms only in the dark, that soft, white, breathing light that surrounds the hidden sun is always there, always radiating, always reaching outward. But you can only see it when the brighter light is covered. This is simply optics, simply the physics of light and vision. But it also, if you let it, speaks to something quieter and more personal, something about what becomes visible when the usual brightness is reduced. What is always there, but normally too dim to see, what the quiet reveals. You have been in the quiet for a while now. Let yourself stay there. There is nothing to do tonight. The eclipse has happened or will happen without requiring anything of you. The moon is where it always is. The sun is somewhere below your horizon, doing what it always does, sending its light forward at 300,000 kilometers per second, arriving without announcement, filling everything it touches. Tomorrow the light will come again. You know this, your body knows this, and knowing it, you can let go of the night. Not push it away, not fight it, but simply allow it to be what it is. A rest, a softening, a space between one day and the next, quiet and dark, and full of a kind of warmth that has nothing to do with temperature. The birds have settled. The spiders have finished what they started or abandoned it for morning. The cows are in the barn. The bees are in the hive, clustered together in the warmth they make themselves. Everything that needed to be done today has been done. The eclipse has passed over its mountains and its coastlines. The shadow has moved on. Let your breath slow. Let your body be heavy. The story will still be here in the playlist, waiting for the next night you need it. The sky will still be turning. The moon will still be tracing its quiet arc. And somewhere in the path of the shadow, on a hillside in Spain or on the coast of Morocco, someone is still standing very still, face turned upward, not quite ready to look away from the place where the sun was covered and the corona bloomed and the stars appeared in the afternoon sky. Close your eyes now. Let the story carry you the rest of the way. You have been somewhere beautiful tonight, to a sky that darkens in the middle of the day, to a sun that wears its light like a crown when the moon passes over, to a world that has been watching these events with wonder for as long as there have been eyes to watch. You are held. You are safe. The light is always coming back. Rest now. The sky keeps watch.